What if I told you that the universe sings, and NASA has actually heard its voice? That's not science fiction, but a real cosmic discovery that changed the way we perceive the silence of space. We've always imagined the cosmos as a place of total stillness, a vast vacuum where sound cannot travel. But what if the universe has been humming a song all along, one we simply never knew how to listen to? Sound, as we understand it, needs air to travel. But in the depths of the cosmos, where there is no atmosphere, how could a melody even exist? That's the question that puzzled astronomers for decades, until one particular signal from a distant cluster of galaxies caught their attention. The discovery was so strange, so otherworldly, that even scientists described it as the universe singing. It's almost poetic, the idea that space itself vibrates with frequencies beyond human hearing. And yet, it's true. What NASA found wasn't just noise or random data. It was a structured vibration, a pattern of energy moving through the hot gases of a galaxy cluster millions of light years away. It wasn't silence. It was a symphony hidden in plain sight. The very thought that the universe could sing challenges our imagination. We've looked at the stars, mapped the galaxies, and measured the speed of light, but we never expected to hear them. The cosmos, it turns out, may not just be seen or felt. It can be heard. And in this story, we'll listen to a song that has been echoing for over 250 million years. And this song doesn't come from just anywhere. It comes from one of the most violent, mysterious, and powerful places in the entire known universe. A colossal black hole that, against all odds, produces a sound so deep it would take 10 million years to complete a single vibration. The Perseus Cluster. Where it all happened. Our story begins in the Perseus Cluster, a vast collection of galaxies located more than 250 million light-years from Earth. It's one of the most massive structures ever observed, stretching across millions of light-years and containing thousands of galaxies. Within this cluster lies a swirling sea of hot gas, glowing with X-rays so intense that NASA's telescopes can pick them up from across the universe. The Perseus Cluster isn't just any region of space. It's a cosmic laboratory where gravity, light, and energy interact on unimaginable scales. The gas that fills this cluster reaches temperatures of tens of millions of degrees, and inside that gas, scientists noticed something odd. Tiny ripples, like waves moving through the air after a sound is made. These ripples weren't ordinary. They were evenly spaced and followed a precise pattern, as if something was vibrating, pushing and pulling the gas in regular intervals. At first, no one believed they could represent a real sound. After all, sound shouldn't exist in space. But the data didn't lie. Those waves, invisible to the human eye, were the signature of something massive buried at the cluster's center, something powerful enough to send vibrations across hundreds of thousands of light years. It was there, at the heart of Perseus, that scientists turned their eyes toward an object unlike any other, a supermassive black hole. And this black hole wasn't just devouring matter or bending light. It was doing something no one expected. It was singing. The black hole at the heart of Perseus. At the core of the Perseus cluster lies a monster. A black hole so massive it could swallow billions of suns without slowing down. This isn't the kind of black hole you find in textbooks. This one stretches the limits of what gravity can do. Astronomers estimate its mass to be more than 10 billion times that of our sun, an object so dense that not even light can escape its pull. Imagine something that powerful, sitting in the middle of a cluster filled with galaxies. Around it swirls a chaotic storm of superheated gas, dust, and radiation, all spiraling toward a gravitational abyss. But while everything nearby is consumed, the black hole itself remains invisible, its presence revealed only by the destruction it causes. From this chaos comes something unexpected. Instead of silence, the black hole seems to pulse, pushing waves of pressure through the gas surrounding it. Each pulse is like a beat, a cosmic thrum, rippling outward into the cluster. The result? A vibration so slow and deep that its note is the lowest sound ever detected in the universe. This note is 57 octaves below middle C, far beyond human hearing. It's not a sound we could ever hear directly, but it exists nonetheless, resonating through space like the baseline of creation itself. If your ears could somehow detect it, the tone would be unimaginably deep, slower than any rhythm on Earth. What's even more astonishing is how stable it is. These waves have been traveling through the gas of Perseus for millions of years, carrying the mark of the black hole's activity across vast cosmic distances. In a sense, the black hole isn't just devouring matter, it's playing a note on the fabric of space itself. The energy required to produce this sound is beyond comprehension. Each oscillation of the gas represents more power than all the stars in our galaxy combined. And yet, this black hole continues to hum, keeping time with the slow heartbeat of the universe. Scientists call it a pressure wave, but in poetic terms, it's more like a gravitational song, one that only instruments, not ears, can hear. It's haunting, mysterious, and strangely beautiful. A reminder that even in destruction, there's rhythm and order. And just when the concept seemed too strange to be real, NASA decided to take a closer look. What they found would turn those invisible waves into something we could finally hear, the first real sound of a black hole. Because sometimes the universe doesn't just show us its power, it lets us listen to it. NASA's discovery. In 2003, data from NASA's Chandra X-ray Observatory revealed something extraordinary. The telescope, orbiting Earth and scanning the depths of space in X-ray light, picked up a repeating pattern in the Perseus Cluster. It wasn't random noise, but it was a steady, rhythmic signal buried in the chaos. The universe, it seemed, was humming. At first, scientists were skeptical. Space doesn't allow sound to travel the way it does on Earth. But the ripples Chandra detected weren't ordinary sound waves. They were pressure waves in hot cosmic gas, like the slow pulse of an enormous drum. These waves moved outward from the black hole in perfect circles, like ripples on a pond after a stone is thrown. When NASA converted these ripples into frequencies we could hear, the result was astonishing. After scaling the vibrations millions of times higher, they became audible to the human ear. And what emerged sounded like something between a haunting choir and the roar of a distant storm. It was eerie, deep, and strangely harmonious. The voice of a black hole, captured by human technology for the first time. Scientists described it as a window into cosmic physics, but artists and dreamers heard something more: the heartbeat of the universe. This discovery wasn't just about sound, it was about perception. For the first time, humanity wasn't just seeing the universe, we were hearing it. The idea that such a distant, terrifying object could produce something musical connected science and art in a way few discoveries ever have. And beyond its beauty, the sound had meaning. Those waves weren't just noise. They carried information about how the black hole interacts with its environment, how it consumes matter, and how it shapes the galaxies around it. The Chandra team realized they were listening to energy in motion, to the very rhythm of creation itself. The Perseus black hole wasn't a silent void. It was a conductor in an orchestra of galaxies, shaping the space around it with every pulse. To make the sound accessible, NASA released the translated audio publicly, and for the first time in history, we could hear a black hole. Millions of people listened, shivering as they realized that the universe isn't quiet after all. And that haunting, alien note, so deep, so slow, so eternal, was the beginning of one of the most profound scientific revelations ever recorded. How vibrations became sound. The moment NASA realized the Perseus Cluster's black hole was producing measurable vibrations, the challenge became clear. How do you hear something that's billions of times lower than the human ear can detect? The answer lay in a process called sonification, the translation of data into sound. Scientists took the ripples in the X-ray data, each representing a fluctuation in pressure across the cluster, and scaled them up by an unimaginable factor, more than 57 octaves higher. Only then did those ghostly waves enter a range we could hear. Suddenly, what had been silent for eons became audible. What emerged wasn't a melody in the musical sense, but a deep, resonant tone, one that seemed to come from everywhere and nowhere at once. It was slow, powerful, and strangely hypnotic, like the echo of a cosmic gong. When the recording was released to the public, people described it as otherworldly, haunting, and spiritual. But make no mistake, this was not an artificial sound effect. It wasn't synthesized or imagined. Every vibration came directly from the data itself. What we hear is the literal imprint of the black hole's influence on space and matter, translated through human technology. The process turned science into art. Each pixel of X-ray brightness became part of a vast symphony, every change in energy a note in an endless composition. What NASA achieved wasn't just a technical feat, it was a new form of perception. By listening to space, astronomers could identify structures and patterns invisible to the eye. The sound became a diagnostic tool, revealing how energy travels, dissipates, and resonates across galaxies. In other words, we weren't just hearing, we were learning. And as the sonified audio spread across the world, it sparked something beyond science, a sense of wonder. For the first time, humanity could experience the universe through its vibration, not just its light. It was as if the cosmos itself had been holding a concert for billions of years, and only now had we tuned in. People described chills running down their spines, as if something ancient and immense had finally spoken. It wasn't the voice of God, nor of ghosts, but something older than both, the sound of gravity shaping existence. In that moment, the Perseus black hole wasn't just a cosmic monster. It was an artist, composing a song of energy and destruction across the void. And the question that echoed in everyone's mind was simple. If one black hole can sing, what does the rest of the universe sound like? The sound the universe makes. The sound of the Perseus black hole doesn't resemble any sound we know. It's not a hum, or a roar, or a simple note. It's an ever-changing tone, deep, pulsing, alive. When sped up to human frequencies, it becomes something eerie, yet strangely familiar, as if the universe were breathing in slow motion. Some listeners described it as a low choir of voices, others as a mechanical drone echoing through eternity. But perhaps the most accurate description is the voice of energy itself. Because that's exactly what it is. Energy in motion, vibrating through the fabric of space-time. Every sound we hear from the cosmos, whether it's a planet's electromagnetic pulse or a star's rhythmic vibration, tells a story about its internal life. The Perseus sound is no different. It tells us how matter falls, collides, and releases heat under impossible gravity. It's the physics of the universe made audible. Scientists often compare it to hearing the pulse of a living organism. Each vibration corresponds to an eruption of energy, an outburst of matter, or a shockwave propagating through the gas. It's not random. It's rhythmic, structured, even musical in its consistency. Listening to it, you realize something profound. The universe isn't still. It's alive with motion and resonance. Every star, every planet, every black hole contributes its own tone to the grand orchestra of existence. And we, on our small blue planet, are just beginning to learn the score. NASA's audio has been played in classrooms, museums, and planetariums worldwide. Each time, audiences react the same way: awe, silence, and a lingering chill. Because when you hear that sound, you're not just listening to data. You're listening to the echo of creation itself. What's even more powerful is knowing that the sound we hear today began hundreds of millions of years ago. Long before humans existed, before Earth even looked the way it does now, the black hole's vibrations were already crossing the cosmos. When those waves finally reached NASA's instruments, it was like receiving a message from deep time, a greeting from a past older than our planet. And yet the sound is happening right now, too. The black hole is still singing, its pressure waves still rippling outward into eternity. The universe, it turns out, never stopped making noise. We just needed to learn how to listen. And as those vibrations fade into the silence of deep space, we realize something chilling. Maybe the cosmos has always been trying to speak. We just weren't paying attention. What these waves really mean. The sound of the Perseus black hole isn't just an eerie vibration. It's a message written in the language of physics. Each pulse, each wave, tells us something about how energy moves through the universe. What we hear is not the sound of air, but of pressure traveling through superheated gas, a kind of cosmic whisper moving through millions of light years. In space, true sound can't exist. There's no air to carry it. But in the Perseus Cluster, the gas is so dense, so hot, that it acts like a gigantic medium for vibrations. These ripples are the black hole's influence made visible, or rather audible. It's a demonstration of how gravity itself can sculpt the universe. Every wave that passes through that gas carries information. How much energy the black hole released, how fast it did so, and how the surrounding matter responded. It's like watching the aftershocks of an explosion in slow motion. The sound is the evidence, the proof of something happening deep in that dark core. What makes this even more fascinating is how constant it is. The waves repeat over and over, forming patterns that tell astronomers the black hole isn't random. It follows a rhythm. Even chaos, it seems, has a tempo. And in the vastness of space, this tempo is unimaginably slow. Each full cycle of that wave takes nearly 10 million years to complete. Imagine that. What to us sounds like a single note is, in reality, an event that spans the rise and fall of entire species. The sound of the black hole is literally time made audible. It's as if the universe itself is breathing, one breath every few million years. These waves expand, cool, and fade, only to be replaced by new ones as the black hole continues to feed. It's a living process, a cosmic respiration we can measure but barely comprehend. Scientists use these vibrations to estimate how much energy the black hole outputs, how it interacts with its environment, and even how it helps regulate the growth of galaxies around it. The sound isn't just beautiful, it's useful. It's data. Through this, astronomers can study the invisible mechanics of the cosmos, the way the gas moves, the balance between matter falling in and energy pushing out. The sound, in essence, becomes a window into one of the most mysterious forces in existence. When you listen to the black hole's song, you're not just hearing something old, you're hearing something alive, a continuous exchange between creation and destruction, harmony and chaos. And the deeper scientists looked into these vibrations, the clearer one truth became. The black hole wasn't just making sound, it was shaping the space around it. What the discovery reveals about black holes, the sound of Perseus did more than amaze the world. It gave scientists an entirely new way to understand black holes. For decades, black holes were considered the ultimate silence of the universe, the point where everything ends and nothing escapes. But now, we know they're anything but silent. By analyzing those pressure waves, scientists realized the black hole's sound was a direct clue to its behavior. The vibrations revealed how it consumes matter, how it releases energy, and how it controls the environment around it. The black hole, it turns out, isn't just a destroyer, it's an organizer. As matter spirals inward, some of it is swallowed, while the rest is ejected as energy. This process sends ripples through the surrounding gas, keeping the cluster from collapsing under its own gravity. In other words, the black hole sings to keep balance in the cosmos. Its voice maintains the structure of galaxies. That idea changed everything. For the first time, astronomers could listen to a black hole's feeding habits. Each low note represented an enormous burst of energy, heating and moving the gas throughout Perseus. Without this cosmic hum, galaxies might merge or collapse more quickly. The discovery turned sound into a diagnostic tool. By converting X-ray data into audio, scientists could detect fluctuations invisible to light. What once seemed abstract, the silent pull of gravity, suddenly had texture, rhythm, and tone. It also blurred the line between science and art. Musicians began to remix NASA's recordings. Filmmakers used them in documentaries. Teachers played them to children learning about space. For the first time, the public could hear the heartbeat of a black hole and feel connected to something truly cosmic. But beyond the wonder, there was a deeper revelation. These sounds proved that the universe is dynamic, responsive, and filled with feedback loops, mechanisms that regulate everything from stars to galaxies. The black hole isn't just an end, it's part of an ongoing cosmic conversation. And just like in music, every vibration matters. Each note, each frequency, each pulse carries meaning. The Perseus sound is more than an artifact. It's evidence that the universe operates not in silence, but in symphony. When we listen to it, we're not hearing chaos, we're hearing balance. The cosmos doesn't just destroy, it creates harmony from destruction. And in that realization lies something truly profound. Maybe, in its own way, the universe has always been trying to tell us that even in the deepest darkness, there's still music. The scale of the inconceivable. To understand the true power of the Perseus black hole's song, we need to grasp its impossible scale. The frequency of the sound wave is so low that it's nearly beyond imagination, 57 octaves below middle C. That's not just out of human hearing range, it's out of the hearing range of any creature that has ever lived. If you could somehow stretch one complete note of that sound into real time, it would take 10 million years to finish a single vibration. In that time, continents would drift, species would rise and fall, and civilizations would vanish, all before the note completed a single beat. Think about that. A sound so deep that it moves slower than the evolution of life itself. The universe plays in a tempo we can't even begin to perceive, a rhythm so vast that our entire history is just a flicker in between two pulses. This is the scale that humbles us. It reminds us how tiny we are in the grand orchestra of existence. The black hole doesn't care if we listen or not. It has been singing since long before Earth existed and will continue long after we're gone. Yet, by capturing even a fragment of that vibration, humanity did something extraordinary. We turned the incomprehensible into something tangible. We gave shape to the invisible. We reached across hundreds of millions of light years and said, "We can hear you." Each wave of sound expands through the Perseus Cluster, heating the gas, stirring galaxies, and reshaping the cosmic web itself. It's not a song confined to one place. It's a ripple of creation that affects everything it touches. When scientists study those waves, they're studying the heartbeat of structure in the universe, the energy that keeps clusters alive, the mechanism that prevents the cold silence of collapse. The sound is not background noise. It's the pulse of balance itself. It forces us to reconsider what time even means. To the black hole, millions of years might be a moment. To us, it's eternity. The sound connects those scales, the infinite and the finite, the cosmic and the human, and that's the beauty of it. Through sound, the universe becomes intimate. What once felt unreachable now feels strangely personal. Because when we listen to that distant vibration, we're not just hearing space, we're hearing time itself move.
The philosophical and poetic meaning. There's something deeply poetic about the idea of a black hole producing sound. It's a paradox, an object that swallows everything, even light, somehow giving something back. A voice, a rhythm, a presence that travels across eternity. It reminds us that even in darkness, there can be creation. For philosophers and dreamers, this discovery struck a chord beyond science.
The black hole's hum became a symbol of the universe's hidden language, one that exists whether or not we understand it. It's a reminder that nature doesn't need witnesses to perform its miracles. The sound also redefines our relationship with the cosmos. We often think of space as distant, cold, and empty, but when we hear that vibration, we realize it's alive. It moves. It speaks. The universe isn't silent. We simply lacked the ears to listen. Artists and musicians began calling it the voice of the void, transforming the data into symphonies, ambient soundscapes, and visual art. What began as astrophysics became something more, a dialogue between humanity and the infinite. Even scientists, grounded in logic and data, admit that there's something hauntingly emotional about it. Dr. Kimberly Arcand, one of the NASA researchers who worked on the sonification, once said, "When I hear it, I feel small and enormous at the same time." That duality captures the essence of awe. This sound bridges the gap between knowledge and wonder. It reminds us that science isn't just about answers, it's about questions so vast they transform us just by asking them. The black hole's song also echoes an old truth. Everything vibrates. From atoms to galaxies, all existence hums at its own frequency. To hear the black hole is to hear a piece of that universal vibration, a reminder that we too are part of the same cosmic orchestra. When you listen closely, you realize that this isn't just a sound from deep space, it's a reflection of ourselves. We're made of the same matter, the same energy, the same physics that created that ancient tone. It's humbling, but also empowering. Because if the universe sings, then perhaps in some small way, we are all part of its song. And maybe that's the ultimate message of Perseus. The cosmos isn't silent, and neither are we. We are echoes of the same creation, listening to the music that made us. Other songs of space. The Perseus black hole isn't the only voice in the universe. Space, it turns out, is full of hidden melodies. Each planet, star, and nebula contributing its own rhythm to the cosmic orchestra. The more we listen, the more we realize the cosmos is anything but silent. NASA's missions have captured sounds from across the solar system, each one more fascinating than the last. When the Juno spacecraft flew past Jupiter, it recorded bursts of radio emissions from the planet's magnetic field. When translated into audio, they sounded like eerie howls, a storm of charged particles swirling through invisible fields. Saturn, too, has a song. The Cassini probe detected electromagnetic waves as it passed through the planet's rings, an almost metallic shimmering hiss that felt alive. It was as if the rings themselves were whispering in the dark, echoing billions of icy fragments colliding in perfect cosmic rhythm. Even the sun hums. Through instruments that detect vibrations on its surface, scientists discovered that our star constantly quivers, a deep, resonant hum caused by waves of plasma moving beneath its fiery surface. It's the heartbeat of the solar system, pulsing with life-sustaining energy. Each of these celestial sounds tells a story. Jupiter's crackles reveal its storms. Saturn's hiss maps its magnetic field. The sun's rumble helps scientists predict solar flares. Just as we study light to understand the universe's shape, we now study sound to feel its motion. Together, these recordings form a new kind of astronomy, one you don't just see, but hear. Every tone becomes a clue, every vibration a conversation between matter and energy. And perhaps most haunting of all are the sounds of collisions. When black holes merge, their gravitational waves ripple through space-time, creating bursts that can be converted into sound. The result is a chirp, short and sharp, marking one of the most powerful events in existence. These chirps, these hums, these cosmic sighs, they all remind us that the universe isn't a void. It's a living, breathing entity, vibrating with energy and motion. Perseus might be the loudest note, but it's far from alone. The universe is a choir of billions of frequencies, overlapping, resonating, and evolving together in a song that never truly ends. And when we listen to them, all of them, we begin to understand that the music of space is the rhythm of creation itself, the universe that speaks to us. When we first looked to the stars, we believed space was empty, cold, silent, eternal. But now, we know better. The universe doesn't whisper to us through sound alone. It speaks through energy, vibration, and motion. It's been telling its story since the beginning of time. We just had to learn its language. The black hole's song in Perseus is more than a scientific curiosity. It's a reminder that the cosmos is dynamic, expressive, and alive. Its tones are the echoes of birth and death, expansion and collapse, chaos and order. Every vibration is a heartbeat of existence itself. Listening to that sound changes something in us. It pulls our perspective outward, beyond the Earth, beyond our galaxy, until we realize how connected we are to the infinite. The same forces that make black holes sing also make atoms vibrate in our bodies. We are the quiet echoes of the same music. And maybe that's why the sound feels so human even though it's not. There's a strange comfort in knowing that something so vast, so ancient, produces patterns we can recognize. Harmony, rhythm, resonance. The universe speaks a language we instinctively understand. When we hear Perseus hum, we're not just hearing a black hole. We're hearing the evolution of the universe, the sound of time stretching, of matter transforming, of energy dancing. It's the sound of being. It's also a testament to human curiosity. For centuries, we looked up at the stars and wondered what they meant. Now, with technology, we can hear them sing, and in doing so, we've brought the cosmos one step closer to our hearts. The universe doesn't play favorites. It doesn't sing for us, but it allows us to listen, and in that simple act of listening, we find meaning. We become part of something greater, witnesses to the grand symphony that has no beginning and no end. In a way, every discovery like this blurs the line between science and spirituality. Because when you hear that haunting, deep tone from Perseus, you don't just understand the universe, you feel it. And maybe that's what makes it so beautiful. We, fragile and fleeting, have found a way to listen to something eternal. The black hole sings. And for the first time in history, the universe has an audience.